Let's start to address the topic of data profiling. It is also called exploratory data analysis and is the first step after data collection. Its main goal is to gain some insight over the data and to get familiarized with the business domain. It is the time to assess the quality of the data, naming difficulties and the adjustments needed. It's in this step that we are able to understand the data richness and to recognize the main opportunities to pursue, which questions to put and which problems to address. This exploratory analysis is mainly done through visualization techniques, exploring a combination of statistical measures and properties. The simplest tool is just to make projections of the data according some of its dimensions of analysis, representing the data as points in space, mostly through scatter plots, either 2 or 3-dimensional ones. In order to increase the number of dimensions to display, keeping us able to discriminate among variables, it is usual to use color, or different shapes and other visual elements. However, human eye tends to be unable to distinguish too many variables at a time, and we are usually confined to 3 or 4 dimensions, 2 or 3 axes, and color. But besides we are able to see the data, most of all, we need to understand it, both each of its dimensions and the interrelations among them. Indeed, we may distinguish between univariate and multivariate analysis. Univariate analysis focuses on the study of each one of the variables individually, trying to characterize it at the highest detail. Multivariate analysis studies the relations among sets of variables, mostly to find the influence of one variable over another. For data profiling, we usually consider 4 perspectives: the data granularity, where we identify the atomicity of the collected data and its level of detail. For example, if the data was collected daily or hourly, per city or just by country. The level of detail for the information to discover depends on this granularity and so its usefulness. The second perspective is also univariate and studies the distribution of each variable, with focus on its centrality and dispersion. Knowing the range of the values for each variable helps to find similarities and dissimilarities among the different variables, which also contributes to the multivariate analysis, in particular with respect to the correlations among sets of variables. In the same context, sparsity focuses on the analysis of domain coverage, being useful to understand if the data covers the entire data space or just some of its regions. Depending on this, we are able to identify possible difficulties and the need to collect more data. The last perspective of analysis is dimensionality, which means to perceive the number of variables describing the data. The larger the dimensionality, the higher the need for more data. And lots of data means more time to process the discovery, but also more challenges to face. While we usually just call big data to very large amounts of data records, high dimensionality also requires special treatment, as we will see later. In other videos, we will focus on seeing the various techniques to perform each of these types of analysis and the most used measures to evaluate similarities between records. See you!